Hey guys, today we're going to be looking at our graphing quads. We kind of started our notes on Thursday after a 3-day weekend, or before a 3-day weekend. So I wanted to kind of go over again the process of going through this. We talked about axis of symmetry and vertex and how to kind of go through finding those two pieces. Today I'm going to bring in the y-intercept and kind of filling out a table and then actually putting that on a graph. The only thing that we kind of have left out or to work with after that are domain, range, and then our zeros, which we've already dealt with quadratic formula. Okay, so we talked about for axis of symmetry, we said there is a formula for this. Okay, one thing I do want to point out for axis of symmetry is it is always x equals a number. It is an equation, so it should be written as x equals. A couple people on Thursday, when we're writing our answers, we're just putting like a number there. It should be x equals that number. So it is an equation, so it is a line. Our axis of symmetry we talked about is found as opposite b over 2 times our a value. Okay, so when we do this, we talked about this is opposite b. Some of you are asking, is it negative? Is it always negative? No, it's our opposite. So when I see this opposite sign there, I'm saying the opposite of whatever b is at that time. So I need to go up here to our original problem. We need to label things. So I have my a, my b, and my c. Again, a is always with x squared, b is always with x, c is always by itself. So if I'm going to plug in opposite b would be negative 4. 2 times my a value would be 2 times negative 2. So again, I'm going to do my top and then do my bottom and then divide. So the top part, there's nothing to do, so it stays negative 4. The bottom part, 2 times negative 2 gets me negative 4. Negative divided by negative gets me a positive 1. Okay, so I just found my axis of symmetry, which is just x equals a positive 1. Okay, so when we get to our graph and we look at that, again, our axis of symmetry is a line that's going straight up and down. Basically, you'll go to the x value of 1 on the x-axis and then draw an up and down, straight up and down vertical line. Usually we just make it dotted because it's not necessarily an actual part of the graph, but it shows us where our graph is split in half. Okay, so this is my, if they ask you for axis of symmetry, this is my equation, x equals 1. Again, axis of symmetry is an equation, x equals a number there. Okay, the convenient or really, really nice part, once we do axis of symmetry, I now have my x value of my vertex. Okay, I didn't do any work there between these two. I just said axis of symmetry was 1, so I put my 1 in for the x value of my vertex. Okay, that's really, really nice. Then when I go to find the other part, my y value of my vertex, we are just plugging in the 1 into each x value up above. So here, what I would have is y equals negative 2. Again, I'm going to put a parentheses wherever the x value is. So I have parentheses 1 squared plus 4 parentheses 1 plus 1. Okay, so everything is set up exactly the same. I have the exact same problem here. All I did was replace each of the x's with the x value I had for my problem up above. So I have a 1 here and a 1 here, replacing each of the x's. This is when you're going to essentially use your calculator, plug everything in exactly the same way. If you're using a phone, you'll probably want to do it one thing at a time and then add up your answers. If you're using your calculator, you can type it in exactly how it looks. So I'd type in a negative, then a 2, parentheses 1, parentheses x squared. Again, the x squared button is right next to the 7. Plus 4, parentheses 1, and parentheses plus 1. When I hit equals, I get 3. So this tells me that my vertex is the point 1, 3. Again, this is that point where our graph turns, whether it's going up or going down. It is that turning point where the graph makes kind of that U shape. Okay, so this is the important point that tells us where our graph is going to turn, whether it's going down and turns going up or going up and turns going down. That is our turning point. It is our vertex. Okay. Our y-intercept is probably the easiest thing that you're going to do for this. Okay. Our y-intercept is whatever our c value is. Okay. My y-intercept is always 0, comma, and then whatever our c value is here is a 1. So it is 0, 1. Okay, it's really, really nice, really, really easy. It is always going to be 0, comma, and then whatever your c value is for your y-intercept. Okay, so we have our axis of symmetry. It tells me that I have a vertical line, or the center of my parabola is going to be at x equals 1. My vertex, or that actual point where the graph turns, whether it's turning and going down or turning and going up, is going to be 1, 3, and I know that it's going to hit the y-axis at 0, 1. Okay? All these things helpful. Okay? So for my vertex, 1, 3, the way I fill out our table is going to be pretty straightforward, pretty easy. Okay? It's basically doing what we did here with our vertex in our table. So we're going to pick a couple x values, and I'll show you exactly how to do that here. Okay? So our vertex will always be our middle point. Notice I have 5 points. The expectation is that you should have 5 points in your tables. The middle point will always be your vertex. Okay? So always middle. Okay? You should have 5 points. The vertex is always going to be in your middle, so I'm just going to put a 1 and 3. Notice I've labeled it x and y. That is the same here. This is my x, this is my y. So I have 1, 3. All I'm going to do to fill out my table then is plug in x values on either side of the 1. So if I have a 1 here, the next number is 2, and then 3. Here I can go back, 0, -1. Okay? This is the part that's really nice. Because we picked the center or the vertex that is going through our axis of symmetry, whatever number I get here for 2 is going to be the same number I get here for 0. That is why it's really nice that it's split right down the middle. So those values are always going to be the same on either side of our vertex. Okay? You can choose to either plug in 2 and 3 or plug in 0 and -1. Personally, if you have a choice, I would stay away from negatives. They're a little more difficult to plug in and sometimes get confusing with their signs. Okay? So what I would do is go through and plug in my 2 and my 3 to find my other 2 y values that I need for my graph. Once you have those, we'll head over to the graph and kind of draw this thing out. Okay? So for this, I've got my 2 here. So all I'm going to do for my 2 is the exact same thing with my equation. I'm going to have y equals -2. Where the x is, I'm going to place a 2 squared plus 4 times 2 plus 1. So again, I went back up to here, my original problem. I replaced each of the x's with our 2. That's our x value that we're dealing with right now. So I have -2 times 2 squared plus 4 times 2 plus 1. Again, if you're doing this in your phone, I would do -2 times parentheses 2 parentheses squared. You might even want to do 2 squared first and then multiply -2 times it, plus 4 times 2 plus 1. Again, I would do them kind of separate. If you've got questions on that, make sure you're asking as you kind of go through this unit. If you're using your calculator, again, you'll just type all of this in. -2 parentheses 2 parentheses squared plus 4 parentheses 2 plus 1. And our answer is 1. Again, notice all I had to do is once I found my answer, this whole thing equals 1. I put it as its y value, and I have a mirror image, well, the exact same thing on the other side. Again, symmetry, axis of symmetry, our parabolas are symmetrical, which means both sides are going to be equivalent. So my y values on either side should match up. Okay? So I'll do the exact same thing using my 3. So now I have y equals -2, 3 squared, plus 4 times 3 plus 1. Again, some of you might be asking, Mr. Schultz, why did you pick these numbers here for my x values? I'm just picking the numbers that are on the either side of whatever I get for my vertex. Okay, my vertex's x value is 1, so I put 1 here in the middle, and then I just chose 2 and 3 because that's the next numbers after it, 0 and -1 because they're the next numbers. Okay, so I'm going to plug in my point here, so I've got -2 parentheses 3 squared plus 4 parentheses 3 plus 1, and this gets me a -5. So again, I put my -5 here, and it has a mirror image up above for -5. Okay. Our goal is to be able to graph this. So now I have some points for me to put onto my graph. Remember, your x value tells us how far left and right you're going to go. Your y value is going to tell you how far up and down. These are 5 separate points, so I should look at my graph and see 5 points on there after I do each of these. All right, I'm going to scoot you guys over here so you can kind of see this piece. So we can kind of see both parts at once. There we go. So we said our axis of symmetry, which you can kind of see right here, is the x equals 1. That tells me that if I go to 1 here, I can draw a vertical dotted line. That tells me this is my axis of symmetry. This is my like kind of middle of my graph. It's kind of hard to see. Yeah, you can see that. Okay. And then I'm going to go ahead and start putting my points on. So -1, -5 tells me -1 is to the left 1 and then down 5. So 1, 2, 3, 4, 5. So that's going to be my first point. My next point is 0, 1. So 0 is right here on our x-axis. This is 0. Y value is 1, so I put a dot at the 1. 1, 3, so the x value is 1. Up 3, I'm going to put my dot there. This right here is my vertex. This dotted line is my axis of symmetry. That's where I'm getting it from. Okay, so those are kind of the two pieces initially that you'll need to be able to label and kind of talk about. Axis of symmetry and your vertex is the first two things we found. Then if you notice, as I go through my other points, 2, 1, to the right 2, up 1, I can see now these are directly across from each other, which is what we should be seeing if you did this correctly. If you see something where it kind of goes up and zigs off or kind of has a squiggle in here, then you know something went off. Okay, something's a little bit different. My other point then is 3, -5, so I'm going to go over to the right, 1, 2, 3, down 5, put my dot down here, and now I have myself, again, you can see it's symmetrical, the same distance from my axis of symmetry or my midline here, so that I can give myself an accurate look at what my graph is. Obviously, if you put the points on there, even if your graph looks like mine was kind of off, we know exactly what you're talking about. Okay? So again, plugging our points in or plugging in our x values, you don't have to do all of them. You'll just have to do these other two because they're going to be the exact same on the other side. I've given you guys kind of a lot today, so I wanted to kind of see if you guys have any questions as we get into class. I'll see you guys in just a little bit.